Hello everyone. So I hope you have gone through our previous recordings and by now you know how to conduct the Sine test and the Wilcoxon test. So we were actually talking about the Wilcoxon test, how you conduct that when you have one sample, right? So there I discuss how to conduct this test, and also then we discuss what is the large sample approximation. That is, even though when you have a small data set, right, sometimes when we cannot apply the parametric methods, we always choose non-parametric methods when you have a small data set, but sometimes when we can use the large sample approximation under certain assumptions, right? So in that cases we discuss what is the large sample approximation according to Wilcoxon test. And then now today we are going to discuss some more parts about the Wilcoxon test, that is what you can do when you have ties. That is, when you look at your data set, right, when you look at your data set, what happens if you have the same observation twice, thrice? Like if the same observation is repeating in your data set, what can you do? So if that is the case in your data set, you have to do something for the adjustment of these ties, right? So what we do is we have to, when you take the rankings of these tied values, therefore you have to use a correction for the ties. So in this case, when you use the correction for the ties, you can see my cursor, this is the correction that you have to use. So we use this formula in order to use the correction for the ties. So I will just now, if you are going to use the large sample approximation for the data set under the Wilcoxon Sine rank test, and if you have tied values, then what you have to do is you have to take the large sample approximation formula and then you have to use this tied adjustment, right? You can see now when you take n into n plus 1 over 4, that is the mean value of the data set under the Wilcoxon Sine rank test. So we have subtract the mean, and when you divide by the standard deviation, you can see in your denominator you have this t to power 3 minus t, this formula, that is the adjustment of the tied values. So you have to incorporate that if you have tied values in your data set. So I will just explain you this one using an example. So let's say this is your data set, right? You can see you have 3, 3, 4, 6, 6, 6. So you have the same number. Now when you take observation number 3, so it's repeating 2 times. And if you take 6, it's repeating 3 times, right? If you take 8, 2 times. If you take 9, you have 4 9. So you have repeated observations. So the first thing when you are applying the Wilcoxon test is you have to do the ranking. So when you are doing the rankings, we can see the smallest number is 3. So we can give 1 and 2 for the two 3's, but since it's the same number, we have to take the mean value of the ranking. So 1 plus 2 is 3. 3 divided by 2 is 1.5. That's how we get the rank 1.5 to these 3's. So the next largest value is number 4, and we can see for number 4 we have the rank as 3 because we have already used. So I just type the ranked values 1 and 2 as the ranks for 1 and 2. So the next largest integer is 4, so we can give the rank as 3. That's how we got the rank 3 for the observation 4. And then when you take the next one, when you take the next observation 6, so for the next observation we can give the rank as 4. So you have another 4, we can give it as 5, and we have another 6, we have we have 3 6s, so we can give 4 for one, 5 to one, and for the other one we can give 6, right? So when you take the total of the ranks, 4 plus 5 plus 6, that is 15. So since we have 3 6 values, so we have to divide it by 3. That's how you get the rank as 555. So like that, first you have to calculate the rank values, right? We know when we apply the Wilcoxon test also, I discussed how to calculate this rank value. So using the same procedure, first what you have to do is calculate the rank values. And then after calculating the rank values, what you have to do, we have to count the tide values. That is when you take the observation number 3, right? So we have 2 tide values. So then since we have 2 tide values, we take the t value of that as 2, right? So and this t value, we are calculating t value only for the observations where you have the tide value. So when you take the next observation 4, it doesn't have a tide value, so we are not going to calculate t value. But when you take the next observation, you have 6, 6, 6. So 6 is repeating 3 times. So there you can talk about tide value. So what we are going to do is then we can calculate the t value. So the t value is 3 because we have 3 6 values. And then when you take 8, you have 8, 8. 8 is repeating 2 times. So therefore we can calculate the t value. T is 2. And then when you take 9, 9 is repeating 4 times. Therefore we take the t value as 4. Right? So likewise you have to take the tide values and see how many times they are repeating, right? So that's how you calculate the t value. So after calculating the t value, then it's easy. You have to just calculate the t squared value, right? So in this case, I'll just for you to clear. Right, so the first t value is 2. So when you take t to power 3, it will become 8. So the next t value is 3. When you take 3 to power 3, that it will be 27. Again, you have 2 as the t value. So t to power 3 is 8. And then you have 4 as the t value. 4 to power 3 would be 64. So likewise, you can calculate the t and t to power 3 in order to do the adjustment for the tide values, right? So I will illustrate this more using this example. So it says the following data show the lifespan in years of a random sample of 28 recorded deaths in a certain country. It has been known in the past years that the median lifespan in the country is 50 years. Can we conclude from these data that the median lifespan in the country has improved? So what you can do is, now in this case you have more than 15 observations, right? You have 21 observations. That is, you can go for the large sample approximation. And here what we have to test is they are given us certain values of a lifespan in a country. And they say the median lifespan is equal to 50. So we have to check whether that is equal to 50 or that has been changed by now. Right, so the first thing is we need to write the hypothesis. So if I'll take M as the, if I take M as the, let's say the median lifespan in years, right? So if I type my hypothesis, the H naught would be, we have to check whether median lifespan is equal to 50 or not. So H naught would be median lifespan is equal to 50, where my H1, the null hypothesis, would be median lifespan is not equal to 50. Right? Sorry. I'm sorry, there's a small mistake. So in this question, we have to find, can we conclude from these data that the median lifespan in the country has improved? So if it has improved, what you have to do is, the claim means we have to check whether the lifespan has improved, whether it is more than 50. So this should be greater than 50. And in this case, when you take the null hypothesis, you can write it as m equal 50, or you can write it as m less than or equal to 50. Both are correct. As you like, you can write it. So the claim is the important one, since we have to test here whether the lifespan has increased. So you have to write the median lifespan greater than 50 as your alternative hypothesis. And then what you have to do is, now we have we have our hypothesis what we want to test, and then we have our data set, and since our data set is greater than 15, we are going to use the large sample approximation. So if you are going to use the large sample approximation, so we have, in our previous lecture, we have discussed what is the formula. So this is the formula that you have to use, because if you have the tide values, you have to use this part as the adjustment for the tide values, right? So you have to calculate the W test statistic, and then you have to, n is the sample size, so that you have no problem, and then you have to calculate T to power 3 and the summation of T values, right? So using this, you can calculate the large sample approximation values. So I'll show you how to calculate these values. So you will see, I hope now you can see this. Just so I think it's visible now, right? So you can see we have 21 data points. So the first task, as you can see, we can take our data set, and it will be very easy if you arrange all the observations as in ascending order, that is from the smallest to largest. So you have 39, 42, 42. Likewise, we have arranged all our data set from as in ascending order. And then what you have to do is, now 50 is the median value. So you have to calculate the difference between the observation and the median value. That is 39 minus 50, that is minus 11. 42 minus 50, that is minus 8. 42 minus 50, that is minus 8. Likewise, di are the difference between the observation and the median value. And then what you have to do is, you have to calculate the absolute difference between the observation and the median value. So that is, here you have minus 11, that would be plus 11. And then what you have to do is, after calculating that, you can rank all these absolute differences, right? So when you have the, you can see when you have like the common values, right? You can see the tide values, like when you observe the differences, you can see the smallest value is 3, but you have 3 3s. So when you give the ranks, you can give 1, 2, 3, and then you have to take the average value. So 1 plus 2 plus 3 is 6. 6 divided by 3 is 2. So that's how we get 2 as the rank for these 3 3s. And since we have the tide values, then we can talk about the adjustment for ties. So we discuss how to calculate the T value. So since in this case we have 2 42s, here the T value is 2, here we have 3 3s, T value is 3, and then we have here 3 9s, so the 3 value is 3, and then here we have again, you can just check it using the difference, so using the observation, same thing you get. right, because as I have written it in the ascending order, you get the same answer. But if it is jumble, it's not, because then the difference, you can get the same difference using two observations. Since you have this in ascending order, you can just identify the tide values if you look the difference column, or else if you observe the observation, right? So likewise, we have to calculate the t value. So after calculating the t value, you have to take the summation of the t, and then you have to take the t to power 3 value and the summation of that. So if you just give a try to this, you will get the summation of the t values as 10, the summation of the t to power 3 value as 70. Right, and in this case what you have to do is now we can see in order to calculate the large sample approximation, so we have the t values, but if you just look at the equation here for the large sample approximation, right, so this is the equation. We need to calculate the z value, right? So I'll just type it here. So we need to calculate the w value. So now in this case, since our alternative hypothesis is having the greater than inequality, right, we are interested in w minus, right, that is the summation of the ranks of the negative differences. So if you get the summation of the ranks of the negative differences according to this example, you will see, you can just give it a try and see, that would be equal to 23. So if I just substitute for this equation, here my w value would be 23, right? That's because w minus is equal to 23. So that's why I have substituted 23 here. And minus, then you have n value here. We have 21 n values. So 21 into 22, you can divide it by 4, right? And then whole thing we have to divide by, then you have to take the square root of, right? If you look at the first one, for the first formula, you have n is 21 into n plus 1 is 22 into 2n plus 1 is 43, divide by 24, minus, then we have summation of t to power 3, that summation we got as 70, right, into minus summation of t values, we got it as 10, divide by 48. So I have not used brackets properly, like very accurately. So you have to use the brackets accurately just to show you how to substitute. So when you substitute these values, you can find the z value, right? So if you just simplify this, right? So if you just simplify this, you will get the z value as this is equal to minus 3.2175, right? Minus 3.2175. That would be your z value. So after calculating z value, now we have to check, we have to get the decision of our hypothesis. So what is the decision of our hypothesis, whether to reject it or accept it? So we know, then what you have to do is, if it is right, then we have to check for the values from the cutoff mark from the standard normal distribution. So in this case, we know, since this is coming from the standard normal distribution, we can just take the cutoff value as the z 0.05, right? So if you take z 0.05 value as the cutoff mark, that would be, in this case, Yeah, so here when you take, if I just illustrate you, if you can't remember how to take the cutoff mark of the Z distribution, now in this case, if you just look at our hypothesis again, so we have to test whether the median has improved, that the median is greater than 50. So what we do is, if you look at our null hypothesis, right, we know that is median is less than 50. So if the median is less than 50, when the null hypothesis is true, our distribution is going towards our left hand side. Right, so in that case we are interested in Z value, that is Z which is in our right hand side. Okay, so if you take the Z value as Z 0.025, right, in this case, so this would be equal to 1.96. right, 1.96. so when you take 1.96, now here we have got a minus figure, right, we have received a minus figure as because as according to our test statistic is minus 3.2175. so it's not inside the critical region, so we can write we have we do not have enough evidence to reject our null hypothesis. So that is, we cannot say that the lifespan has been improved in this country. So that's how you can use the large sample approximation when you are applying the Wilcoxon test. And also now in this case we can use we can also find a confidence interval using the Wilcoxon Sine rank test. So I will illustrate that confidence interval also using an example. Now if you look at this one, so let's say this is your data set, you need to find a 95% confidence interval for the population median by the Wilcoxon Sine rank procedure. So if that is the case, the first thing you have to do is you have to arrange your data set in ascending order. So you can see here you have 25, 26, 28, like this you have the ascending order. So first you can write all your values as a column and as a row. Why we write this value? So why we write your data set as a column and a row? We are going to take all possible pairs and calculate the average of all possible pairs. That is, if you take the first value 25, 25, it's one possible pair. So if you calculate the mean, 25 plus 25 divide by 2 is 25. And then if you take 25 plus 26, these two pairs, then you will get the mean value as 25.5. So when you arrange your data set like this, if you take one diagonal, you can calculate the mean values, right, which are above the diagonal or low, which are below the diagonal, because the values are symmetric, right. So you will get all the possible pairs, all the possible mean values, right, using all the possible pairs when you calculate your the means using this method. So if you are going to find a confidence interval using the Wilcoxon Sine rank procedure, that's the first step you have to do. So after calculating these mean values, then what you have to do is you have to arrange these mean values again using ascending order, and then after arranging the mean values in ascending order, right, we can find an estimate. We can find an estimator for the median. So when you want to find the estimator for the median, what you have to do is we can just find a point estimator for the median, because here if you just count how many possible mean values that you have calculated when your data set, if you have n number of values in your data set, when you calculate all the possible mean values, actually you can just calculate and see, you will get n into n minus 1, sorry, n into n minus 1 divide by 2 plus n number of pairs. Right, so I'll just illustrate using this. So here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations. So as for this case, your n value is 10. Right, so that is, you can write 10 into 10 minus 1 is 9 divide by 2 plus 10. So 10 into 9 divided by 2 means 90 divided by 2, that is 45. So 45 plus 10, that is equal to 55. So if you count here, you have 55 mean values. Then we can just, as for a usual row data set, we can find the position of the median, that is n plus 1 divided by 2. So since you have 55 mean values, 55 plus 1 divide by 2, that is 56 divided by 2, that is the 28th observation. So as for the point estimator for the median, you take the mean values and find the median of the mean value. So if you just check here you have so many mean values. If you arrange these mean values as in ascending order and check what is the 28th observation, you will see that 28th observation, right, from this data set. So that you can take the 28th observation as your point estimator for the median. So according to this data set, the 28th observation would be 32. So according to this example, the point estimator for the population median is 32. Right, and then what you can do is, now we know what is the point estimator value, and then what you can do is, now we can find the confidence interval. So in order to find the confidence interval, first we have to use the Wilcoxon Sine rank test. Right, so in order to use the Wilcoxon Sine rank test, so here we have 10 observations. So if we are going to find out a 95% confidence interval, what you have to do is, using Wilcoxon Sine rank test, if you are going to find the 95% confidence interval, so the alpha value, we are taking is 0.05. right? So if you what we have to do is, in this case, we have to take alpha divided by 2 value. So alpha divided by 2. So since it's a 95% confidence interval, so that is 0.025. So here n value is equal to 10, right? N value is equal to 10. So what we are going to do is, now using the Wilcoxon table, we are going to find, using Wilcoxon table, we are going to find W10, 0.025 value using the Wilcoxon table, right? So if you can remember, when we use the, I have already explained you how to use the Wilcoxon table. So using the Wilcoxon table, we have to check this value, W10, 0.025 value. So I'll just show you how to check this value. So if you look at the Wilcoxon Sine rank test, now if you look at the sample size n, you have 10 here, right? And then if you look at the two-tail test and alpha value, and if you look at the one-tail test, again you have alpha value. So if you are going to find a confidence interval, we have to check for the two-tail test, right? So if you are checking from the two-tail test, here they have already, you have to check with the alpha value, not alpha divided by 2. We are actually looking for the alpha divided by 2 value, but they are giving us directly the two-tail test value. So from the table, we have to check alpha value. So as for our question, the alpha value will be 0.05 since we are interested in 95% confidence interval. So alpha is 0.05 and sample size is 10. So at the intersection point we have the value as A. So that is this W value, this value we can read from the table as 10. Sorry, 8, right? From the sample size we have 10 and from the two-tail alpha 0.05 at the intersection point we have 8 as the value. So what you have to do is this value we can read from the table as 8. Right? So what we do is now we calculate a value as K. So K is equal to T plus 1. Right, where T is equal to this table value. So from the table we got the value as 8. So K is equal to T plus 1. So in our case that is 8 plus 1, where that is equal to 9. So when you calculate the confidence interval, the lower limit, how you are going to find the lower limit is equal to K smallest value. K smallest value. Lower limit is equal to kth smallest value. And then if you take the upper limit of your confidence interval, that is equal to the kth largest value. Right, so how you are going to do this? Now you have your data set and we have calculated the all the possible mean values. From the mean values you have to arrange these 55 mean values in ascending order, and then you have to see what is the 9th smallest value. Now if you look at this, you have this smallest one as 25. Right, so likewise you have to check what is the smallest observation which is in the smallest observation, smallest kth observation according to this data set. So in that case you will see, if you check the value, that would be equal to 28.5. right, because here you have 25, 25.5, you have 26. Likewise, if you just check what is the smallest kth value, that would be 28.5. And likewise, if you check what is the largest kth value, so according to this example, the largest value is 41. Then you have 40.5, then you have 40.0, then you have 39.5, then you have 39. Likewise, so if you count, this is the first one, second, third, then fourth, fifth, sixth, seventh, eighth, ninth, largest one is 35. Right, so likewise we can find the 9th smallest one and the 9th largest one. So the 9th smallest one, since it is 28.5, and the 9th, so this is the 9th smallest one, right? And then we have the 9th largest one as 35. So according to a 95% confidence interval for the population, 95% confidence interval for the population median, we can give as 28.5, 35. This is a 95% confidence interval for the population median, right? So this is how you find the confidence interval using the Wilcoxon Sine rank test. And if you're using the large sample approximation, as for your k, how to calculate this k value, you have to just use this equation. That is the only difference if you are using the large sample approximation, how to find the confidence interval. So I hope now you know how to use the Wilcoxon test and the Sine test. Sine test accurately based on your scenario, and how to calculate the confidence intervals, and how to use the large sample approximations. So there are some questions where you can give a try and let me know if you have any difficulty, then we can discuss. Thank you so much.